Hi ladies and gentlemen, in this video I tell you about iterations and conditions in Python. I will tell you about iterations using for loop and while loop, and we will invoke conditions with if, elif and else statements. So let me start with that presentation. The speech is organized into your learning outcomes, then iterations with the while statement, iterations with the for loop, and invoking conditions with if, elif, else statements. And we will see some simple applications like the oscillating mathematician problem, and then you will see vectorized computing versus iterations. So what you will learn are you will learn iterations with while and for loops. You will learn to invoke conditions with if, elif, else statements. You will learn vectorized computing and compare with iterations. Usually iterations in Python are slower than vectorized computing. So with vectorized computing, you can achieve fast results. You will analyze the oscillating mathematician problem with the iterations. Now let us look at the while statement. See this code that is from SciPy import stuff. That line imports all the modules in SciPy. I initialize I equal to 0, then while I is less than 10, after that there is a colon. That is very important. While I less than 10, then there is a colon. Then what remains after the colon, that is that comes as an indented block. What comes under the while loop, that comes as an indented block. Print I is I plus 1. So this loop runs until I becomes 10. Now this indentation is very important. Python identifies code blocks by indentation. In C programming, if you write all these things in one line, all the code in one line and executed, it will still be executed. But here it is not like that. But even in C programming, good programmers always use indented blocks for code segments. So this is how we write a while loop. We will run this code. This is a while loop, print I while I is less than 10. Let me run this code. I will clear this. Run while loop py. You can see that it prints numbers from 0 to 9. Okay. Now let me go back to my presentation. If this indentation is not there, it will raise an exception. If I remove this indentation and put this way, it will raise an indentation error. So Python identifies code blocks by indentation. I press a tab and keep it that way. Next, let us append a value to an array, values to an array. Like I import all modules from SciPy with from SciPy import star array. A blank array is created with arr equal to blank. I equal to 0 while I less than 10. Array arr dot append I. Append is a function from SciPy. It appends values to a list or an array. I is incremented to I plus 1, then print arr. And this will run like this. I go here, while I this is a code, while I less than 10 arr dot append I. Here I can run this code app dot py. You can see that the blank array is appended the values appended with values from 0 to 9. Now another way of iterations is with a for loop. See this code that is from SciPy import star. That line imports all modules of SciPy. For I in range 0, 10, print I. This here also note this colon and the indentation. For I in range 0 to 10, range 0, 10. A range is a function from SciPy. This is a vector of values from 0 to 9. And print I. So this prints these values. Here also that whatever happens in the for loop, that comes as an indented block. Now let us look for that code. This is for print. This prints these values. So let me go back to this presentation. You can append values to an array with for loop. Here you start with a blank array. For I in range 0, 10 ARR dot append I print ARR. That will look like this. Here also it does the same thing. Now you can invoke conditions with the if, elif, else statement. Now this code reads a number from a terminal, an integer from the terminal using the input function. So from SciPy import star as usual, then print enter a number, enter an integer. Means this will this will print a prompt, enter an integer at the terminal. Then x equal to int input thing. This will read the input value and convert to an integer. So if this integer value is less than, this int is doing that integer conversion. Input is a raw input reading from the thing that may be read as a string, so that is converted to an integer. So if x is less than 10, print the entered number is less than 10. If x is greater than 10, and this is a logical AND operation. Elif x is greater than 10 but less than 100, less than or equal to 100, and this is a logical AND operation, print the entered number is between 10 and 100. Else, if it is more than that, three conditions are invoked here. You can add another elif also, multiple elif, no problem. Else, print the entered number is greater than 100. This is a very simple way of invoking conditions with the for loop. So here you, with the if statements. Here you can see this thing. This is code 3. I will run code 3. See, I number 678. So it says the entered number is greater than 100. So if it is, I say 4, say it is less than 10, or I say 15, it says it is between 10 and 100. So these are our invoke conditions with if else statements. Now there is another problem. That is a oscillating mathematician problem. There is a mathematician who she is good at mathematics, but she is very bad at making decisions. So one day she starts working from her home to office at unit distance. So she starts working from her home. Halfway she stops. Okay, she decides, oh, let me go home. She walks back. When she reaches half of that distance, around 0.25 meter, again 0.25 kilometers, say, she stops again and she goes back to the office. So when she covers half of the remaining distance, she again stops and walks back. So she keeps on walking like this. So what will be her final position? So we will prove that if she keeps on walking, she will be walking between 0.3333 kilometer and 0.666 kilometer. She continuously walks. If she indefinitely walks, she will be stuck between 0.1/3 and 2/3. So we will do this by iterations. First, I need to plot something. I need the math libraries from SciPy import star. From pylab, I need to plot something. So I invoke the pylab library. So her positions are here. I put a position in a blank array, values of her position in a blank array. I start with the old position as a 0. This is her home. Her office is at unit distance. So for I in range 0, I do some 50 iterations. So for I is some 0 to 50. So if for 50, I do these iterations. So if I is an even number, that is a iteration. Either it is a 0th step or second step or fourth steps. What happens is the new position. Her new position is old position minus old position into 0.5. Okay, old position minus old position into 0.5. Else, if she is taking steps like iterations 1, 3, 5, etc., her new position will be old position plus 1 minus old position into 0.5. Okay, so then the old position becomes the new position. These values are new values are added to these new position values are appended to my blank array. So then I plot the values. X labels are given, Y label is a distance, grid is on, and show. I will show that she will be she will be indefinitely working between the points 1/3 and 2/3. The solution is here. Oscillating mathematician problem. So let us run this vazi.py. You can see that this graph shows her positions. Initially her position is at 0, then she goes to 0.5, then she comes back to 0.25, then she comes back to 0.25 plus half of the remainder, half of 0.75, that way, until you can see that as the iterations go along, you can see that this position is 1/3 and this position is 2/3, that is 0.666. So she ends up working between 1/3 and 2/3. Vectorized computing. So iterations are there, like when I add values to an array or something with the for loops, it is very time consuming. So we'll compare this appending by iterations with vectorized computing. So vectorized computing is much faster than that. So it's always in Python, vectorized computing is always preferred. So here I do some 10 million iterations to append values to an array. Say I start with a blank array, I take n as say 10 million, and here I compute the time with the time module. So from SciPy import star, that imports all SciPy modules. Then I import the time module also, that computes the time of that returns the time of computation of certain iterations or whatever computation is happening. Array is a blank, n is a 10 million. T1, here I need to compute the time of this for loop. So I initiate a time here, T1 is time.clock. For I in range 0, n array.append I. So 10 million values are added to this blank array. First 10 million numbers are added to this blank array. So how much time it takes? It computes T1. So what is the time after that? T2 is time.clock. Then print T2 minus T1, so I can know. Now I can execute the same thing by using the range function. Range 0, n will give me a vector of length 10 million. That is, these values are from 0 to 10 million minus 1. Okay. So what is the time needed for that? If I compare this time, T2 minus T1 and T4 minus T3, you can see that the vectorized computing is much faster than iterations. This is a code. I will compare this. You can see that the first time it takes about 0.9 second, that is for iteration takes about 0.9 second, while my vectorized computing using the range function, that takes only 7 microseconds. So this is how you can establish that the vectorized computing is much faster than my array operation, my iterations. You will see more vectorized computations as you go into scientific computing. What you learned in this session are you learned the iterations with while and for loops, you learned the conditional statements with if, elif, else. Then you understood the meaning of vectorized computing, you compared with the iterations. Then you analyzed a oscillating mathematician problem with the iterations. Now that is the end of this presentation. I thank you all.